Hi, and good evening, algebra students. Ms. Daigle here again. Today we are going to be using arithmetic sequences to model a real-life situation and solve problems. Today during class we set up our ISN, so if you did not get it set up, please pause the video and do so now. And also today in algebra we used, this should be page 22. You should have taken some notes on page 22, and today you will be taking notes on page 23 and writing your whisk at the bottom. You should take some really good notes as I go through these problems. What I'm writing down, you should be writing down in your notes, because we are going over how to change an arithmetic sequence into slope-intercept form. So that is some key things that you need to write into your notes. Okay. So Ivors, however you want to pronounce it, Ivors has a new ant farm. He has recorded the number of ants in the colony each week for the first 4 weeks. If Ivor assumes that the ant population will continue to grow at the same rate, how can he use an arithmetic sequence to investigate the population growth? Okay, so first the graph shows the population of Ivor's ant colony over the first 4 weeks. We assume that the population will continue to grow at the same rate. Does this data represent an arithmetic sequence? How can I tell? I can take the total number of ants of 215 to 241 and see if there is a difference. If I subtract the 2 of 241 minus 215, I get a difference of 26. If I take 267 minus the 241, I also get a difference of 26, and then 293 minus 267, I also get a difference of 26. So is this an arithmetic sequence? Yes. How do we know that it is? Because it has a common difference. Very good. Okay. So now that we have determined that the data represents an arithmetic sequence, determine the common difference or the rate. Well, we already determined that the common difference was 26. Very good. So now I want you to write a function formula to represent this data, and these are where you need to start taking some notes. We know from Friday's lesson and practice today that our function formula is written as Tn equals T1 plus D times n minus 1. So if I know that I have Tn equals, what did I start with as the ants? What is my first term in the sequence? 215, very good. Plus, we determined our common difference was 26 times n minus 1. We don't know n yet. That is the number we will be looking for. So we just leave the n in the problem. Now, it says to write it in function notation. Function notation is just using f of n, as we talked about on Friday. F of n equals 215 plus 26 times n minus 1. This is in function notation. This is a function formula. This is in function notation. Same exact formula, same exact equation, just one written in function formula, one written in function notation. Okay, so now this is our function notation form. F of n equals 215 plus 26 times n minus 1. I want you to write it in slope-intercept form, and this is where you need to start taking notes so you understand how to change something into slope-intercept form. To change into slope-intercept form, first of all, let's remember slope-intercept form is y equals mx plus b. Okay, could I also write slope-intercept form as b plus mx? Of course, as long as the m is combined with as being multiplied by the x. So take my 26, I notice that the 26 is being multiplied by n minus 1. So my first step is to go ahead and distribute here. So I have f of n equals 215 plus 26n minus 26, because I rainbowed out that 26 by being multiplied, and we call that the distribution property. So now I see I have some like terms of 215 and a negative 26. So when I combined 215 and a negative 26, I get f of n equals a positive 189 plus 26n. Is that written in slope-intercept form now? Yes, I have an mx. My x has been represented as the n, plus my 189. Can I rewrite this to where my mx is first? Absolutely. F of n equals 26n plus 189. These two, written in red, mean the same thing. So how many ants did Ivor have after he started his ant farm? So if I look at my formula of f of n equals 26n plus 189, and I know that my formula, my slope-intercept form of y equals mx plus b, my b is my starting amount, then I know right now, what did he start his ant farm with? At 189 ants. Very good. Okay. So then now I want to know how many ants did Ivor add to his farm each week? Well, again, in my formula of y equals mx plus b, what is my rate of change? What is it changing by? That is the m. So when f of n equals 26n plus b, what am I changing by? 26 ants each week. Very good. Okay, so use either the original notation or the function in slope-intercept form to answer the following question. How many ants did Ivor have in his ant farm after 20 weeks? Well, first of all, let's determine what does 20 weeks represent. Where are my weeks at? It's the x value, which in this case, when I have f of x, we are representing the x as what? N. So can I take 20 and plug it in for n? Very good. So I can take f of n, and I'm going to use the slope-intercept form right here of 26n plus 189, and I can find where 20 goes. And remember, when the 20 is inside the parentheses at f of n, that is representing the n, so I would plug in the 20 for n. Well, solving my two-step equation, I multiply first. 26 times 20 gets me 520 plus 189 gets me a total of f of 20 equals 709 ants. So after 20 weeks, he will have 709 ants. If I solved using this formula up here, should I have received the same thing? Absolutely. Let's try it. 20 minus 1 is 19. What is 26 times 19? It is 489, so I'm just writing this off to the side. If I have 215 plus 494, I should also receive 709, which is what I did. So no matter which formula you use, we should have received the same answer. Okay, so when the colony reaches a total of 1,385 ants, Ivor's ant farm will not be big enough for them all. In how many weeks will the ant population be too large? So right now, we know that 1,385 ants is too big. So we want to determine n at how many weeks will he be at 1,385 ants to where it is not big enough. Okay, so if this is the total, does it go in N for the number of weeks, or does it go in the Y for the total number of ants? Very good. It goes into the Y section. So this is going to replace all of f of n, because remember, f of n represents my Y. So as I replace that, I get 1,385 equals 26n plus 189. This is just a basic two-step equation we should be able to fly through. I minus 189 from both sides, so 1,385 minus 89 gets me 1,196 equals 26n. Okay, next step in a two-step is to divide by 26, divide by 26. When I divide it by 26, n equals 46. So right now what this is telling me is that in 46 weeks, the ant farm will not be big enough to hold 1,385 ants. Very good. Okay, if Ivor's ants have a mass of 1.5 grams each, what will be the total mass of all of his ants in 13 weeks? So what is the question truly asking for? It's really asking for the total mass of all the ants that will be in there after 13 weeks. Do I know right now how many ants are in there for 13 weeks? No. So I need to take f of 13 and find out how many ants will be there at 13 weeks. So we can solve this right now. 26 times 13 gets me 338 plus the 189 I started with. So after 13 weeks, he will have a total of 527 ants. Okay, but that's not what the question really asked for. The question asked for how many, what was the total mass of all of his ants? Well, think of the ants right now. They're at 1.5 grams each. You're at 527 ants. So I need to take this and multiply it by 1.5, the mass of each ant of 1.5 times the total number of ants. And when I do, I get a mass total of 790.5. So therefore, what this is saying, in 13 weeks, the colony will have a mass of 790.5 grams. Good? Okay, so that is modeling arithmetic sequences within a relation or situation. I hope you took really good notes today. If not, please rewatch the video and make sure that you have the notes on how to change the original function into function formula, into slope-intercept form. That is a key concept here within this video. Okay, so make sure that you are ready for your assessment tomorrow, that you have completed your assignment today, which was studying arithmetic sequences, and come ready for your assessment tomorrow. Thanks and have a great day.